Think of the last thing you threw away. What was it? Why did you throw it away? How long had you had it? How soon are you going to get it again? All of these questions can be answered relatively easily. But wait, what happens to it when you throw it away? Where does it end up? How long is it there? What will it become? Maybe these answers aren't so clear. From a statistical standpoint, there's a pretty solid chance that the last thing you threw away was probably something plastic, given that plastic accounts for roughly 13% of the mass of all waste generated. And that's by weight, so the fact that plastic is relatively lightweight makes it even more likely, especially for disposable products. But what happens when you throw it away? What does it mean to throw it away? We are all familiar with the intended role plastics play in our daily life, but in reality, what we use plastics for barely scratches the surface of what they are currently doing. It isn't until after they are thrown out that plastics truly start to fulfill their real niche, damaging the environment on a global scale. To understand how plastics directly impact environments, the global distribution and presence of plastics must first be understood. To start, all sources of plastic come from the land. Landfill dumping and litter are the two primary sources plastic can enter an ecosystem from. Due to wind, rain, and many other forces, plastic frequently makes its way into the watersheds, where it flows with the current and subsequently ends up in the oceans. But there are also currents in the ocean, and this results in an uneven distribution of plastic across the globe. A lot of plastic ends up along beaches and shorelines. For instance, anywhere between 500 and 2,000 pieces of debris and litter, on average, can be found per kilometer of shoreline on the east coast of the United States. In heavily polluted beaches, plastic can make up over 3% of the total weight. Out in the open ocean, wind and ocean currents circulate plastic and other debris around where they accumulate into massive pools. The poster child for these pools is the Great Pacific Garbage Patch, located in between Hawaii and California, and is estimated to take up a surface area of roughly 3 times the size of France. It is almost entirely made out of plastic, and about half of that plastic is from old fishing supplies, in particular old fishing nets. It is these large fishing nets that begin the complex problems associated with plastic waste. Large-sized plastics can entangle and kill countless forms of life, including but not limited to small fish, big fish, turtles, seals, and even birds. Whether it be a fish or reptile, mammal or bird, large-sized plastics in the ocean pose a universal threat to marine life. Moving down to smaller-sized plastics, such as bottles and bags, the negative impacts only become more extreme. Plastic ingestion is a serious problem for many animals. For example, whales are consistently shown to have ingested large quantities of plastic. This whale, according to one article, was a 2-ton whale that had no food in its stomach, only plastic, and had to be euthanized. Over 30 plastic bags were found inside its stomach. Yet, whales are the largest creatures in the ocean, so perhaps only animals their size could ingest plastic pieces, right? However, the majority of plastic that is ingested by various organisms are barely even visible to the human eye. These are called microplastics, and are considered to be any plastic particle smaller than 5 millimeters in diameter. Plastics are made from polymers that have a really strong chemical bond, and are thus really hard to chemically break down. They form from the fracturing of larger plastics, such as bottles and bags, into smaller and smaller pieces over time. Once ingested, microplastics are often passed through the digestive system, but are occasionally absorbed into the tissue and flesh of the organism, meaning their predators can inherit the plastic they ingest. A study in 2013 showed that microplastic consumption resulted in decreased energy reserves in marine worms. These worms are at the bottom of the food chain, and so their health consequently determines the health of the fish that eat them, and the fish that eat those, and so on. And when it comes to fish that are consumed by people, microplastics make no exception. As stated earlier, the concentration of plastic in the oceans varies greatly based on location, and so that plays into which fish are most susceptible to plastic ingestion. In addition, the behavior of fish also affects their consumption of plastic. For example, Atlantic cod tend to live and feed above the ocean floor, but below the surface. Plastic is most concentrated at the surface of the water or where it is sunk to the floor, so cod are actually on the lower end of exposure compared to many other regularly eaten fish. Yet cod have still been found to ingest considerable amounts of plastic, with one study finding that 2.4% of cod they collected had ingested plastic. This same study claims that this is the lowest ingestion rate of any fish studied in the North Atlantic. So let's paint a picture here. Dwayne "The Rock" Johnson allegedly eats over 2 pounds of cod every day, which totals over 800 pounds annually. If each day he ate his fish from a different cod, then Dwayne almost certainly consumes plastic directly from cod every year. And this is just from cod. Other commonly eaten fish, such as bluefin tuna, have ingestion rates of over 30%. 1 out of every 3 tuna have plastic somewhere in their body. While microplastic ingestion and its corresponding effects are just beginning to be explored, the current information we have begs a very important question. Is the plastic we throw away ending up inside our very own bodies? Too ironic to be true, right? But maybe it doesn't matter. Is one tiny microscopic piece of plastic inside one fish really that dangerous of a thing to consume? I'll be nice and mistakenly assume that eating a single tiny piece of pure plastic would have negligible effect on a person's health. But here's the catch. There ain't no such thing as a pure piece of plastic floating in the ocean. It has been found that the unique chemistry of microplastics allows for pollutants and hazardous chemicals in the ocean to adhere and stick to them. In other words, think of all the dangerous chemicals people have ever dumped into the ocean. Industrial waste, fertilizer, pesticides, and obviously, oil. Microplastics essentially act as a vessel, collecting these chemicals and providing them an easy entrance into many organisms. This is one of the reasons why it is so hard to understand the risks associated with microplastic ingestion. Because in order to understand them, you must also understand the risks of ingesting everything else we have already put in the ocean. So perhaps after hearing all this, you are convinced that recycling rates need to skyrocket in order to curb the problem at hand. But when it comes to plastic, recycling alone isn't going to eliminate the problem. With the national amount of total plastic waste being recycled resting at about 10%, there's a huge way to go in making any considerable difference in the amount of plastic flooding the ocean. Despite the fact that it realistically isn't possible, even if we could recycle somewhere around 90% of all plastic, this still will not be able to last for very long. This is because the overwhelming majority of plastic is made out of petroleum, and so when the world's petroleum reserves are finally exhausted, the value of using plastic will also diminish. So, what the hell are we supposed to do? I'll end by saying that the use of plastic needs to be minimized as much as possible. Not on a pragmatic scale, but on an absolute scale. While this transformation seems daunting, there are already so many ways we can drastically reduce plastic waste with negligible costs. For instance, go shopping with reusable bags. Bring your own bottles and mugs to work or class, and support initiatives to hold corporations responsible for their irrational and dangerous waste disposal. While we cannot instantly eliminate plastic from every facet, we must start now with small steps and build our way towards a truly sustainable future in all dimensions of our life.